Topic 3 for this worksheet covers problem solving with the formulas for volume. Okay, so it's important that you understand that volume represents the space occupied by a three-dimensional figure. We also need to know that volume is measured in cubic units. So remember from previous examples, we talked about perimeter and area. So envision a room, your bedroom, a living room, a classroom, something like that. The perimeter is just the length of all the walls added up. Okay. Oftentimes rooms will have baseboard at the bottom of the wall. Envision adding up the length of all the baseboard. That's your perimeter, and that's just measured in linear units. When it comes to area, we have to look at the surface of the floor. Is your floor covered with carpet, hardwood, linoleum, tile? Whatever that covering of the floor is, that represents the area of the floor. It's a two-dimensional measure, and it's measured in square units. Okay. When it comes to volume, envision the air that fills that room. That's the volume, and it's going to require cubic or three-dimensional units to fill in that space. So we would measure volume in cubic units. So feet cubed, inches cubed, miles cubed, whatever the case may be. Now, there are many different formulas for volume. Volume, you'd be finding the volume of three-dimensional figures or solids is what we'll call them in math a lot of the time. For this example, we're just going to do two types of solids or two types of these three-dimensional figures, but there are many of them, and we have formulas individually for each of those. So let's look at example 3. So example 3 says solve each problem, include units with the final answer. So part A says a basketball has a radius of 4.5 inches. If 350 cubic inches of air are pumped into the ball, is this enough air to completely fill it? Or to fill it completely. And then it says use the formula V, think V for volume, equals 4/3 times pi times r to the third. And for this one, we're going to use pi equals 3.14. So we are going to estimate this using 3.14 as our estimate for pi. Okay, so what we need to do is we need to figure out the volume of this basketball, and then we need to compare that to the 350 cubic inches of air that have been put into this basketball. We need to know, is the basketball full or not? Okay, so we've got the radius of this basketball is 4.5 inches. So we're going to take the volume. We know it is 4/3 times 3.14 for pi times 4.5 cubed. Okay. Now we have to follow the order of operations. We have exponents here and we have multiplication. I'm going to go ahead and take care of the exponent because that comes first in the order of operations. So using a calculator, I get 4.5 to the third power, which is 91.125. So we get, oops, let me do volume first. We have volume equals 4/3 times 3.14 times 91.125. And 91.125 is just 4.5 cubed. Okay. Now you can multiply this all the way across. And I will show you this on the calculator. There's a couple of different ways you can do your 4/3. Okay. So let's go to the calculator. Okay, when it comes to typing in 4/3, there's two ways to do it. One, which is kind of like the old school way when we had calculators that maybe weren't quite as fancy as this, you would just use parentheses, and then you would do the numerator divided by the denominator. So 4 divided by 3, and then I would just multiply by 3.14 for pi, and then I could multiply by the 91.125, which was 4.5 to the third power. Hit the wrong button. And we get 381.51. Okay, so that's the volume of this particular basketball. Another way you could type in the 4/3 is this. On your graphing calculator, you're going to have this green alpha button. If you hit the alpha button and then follow it by hitting the y equals button, so alpha and then y equals, the y equals, when you do alpha y equals, it's going to pull up a fraction menu. And we want to choose option 1, which just does the numerator over the denominator. So you either hit enter or you hit the 1. And what it does is it inputs a fraction into your calculator, and then you fill in the numerator and the denominator. Well, the denominator would be 4, or the numerator, bless my heart, the numerator would be 4, the denominator would be 3. And then you just want to use your right arrow to move out to the front of the 4/3. And then you can type in times 3.14 times, instead of doing the 91.125, let's say you wanted to type this into your calculator all at once, we could do parentheses, 4.5, and then the caret button. That puts us into that like superscript exponent world. And the caret button's just here above the division symbol, and then the 3. And again, we're going to get 381.51. Okay, so either way you type this in, if you do it piece by piece, if you type in the fraction using just the parentheses 4 divided by 3, no matter what, you're going to get 381.51. So let's go back to the worksheet. Now we have that the volume of this basketball is 381.51 inches cubed. Okay, that's the actual volume. What we've been asked is 350 cubic inches of air enough air to fill the basketball completely? And our answer would be no. 350 cubic inches of air is not enough. In order to fill the basketball completely, we would need 381.2 or 381.51 cubic inches of air. So the final answer here would be no, it's not enough air. Okay? Now, for part B, we're looking at a cylinder. So a cylinder, we all know what a basketball looks like, okay? A cylinder, think like a can of soup. You've got something that's like this. Pretend that's perfect, and from an artist, squint your eyes if you must, but that's a cylinder. Okay, so what's happening with a cylinder is you have a base, the bottom of the cylinder, the top of the cylinder, whatever, would be a circle, and the circle has some kind of a radius. And then the whole figure has some kind of a height. So ultimately what we do is we take the area of the base, that circle, and then we just multiply it by the height, and then that's going to give us the volume of this particular figure. So notice here we have the, not the volume, well, the volume, yeah. Here we have the area of the circle, okay, pi r squared, and then we just multiply it by the height, okay? So the volume, pi r squared, that's the area of the circle, multiply it by the height, and that gives us that three-dimensional space that we have to fill in, okay? So here we have a cylinder with a radius of 3 inches and a height of 5 inches, has its height doubled, okay? So initially speaking, we have a radius of 3 and a height of 5. But then at some point, we're going to take that same cylinder and we're going to double its height. So the radius stays 3, but now the height is 10. So how many times greater is the volume of the larger cylinder compared to the volume of the smaller cylinder? Well, imagine an artist has drawn these pictures, or some computer program has drawn these pictures, and they're absolutely perfect. We know that if the radius is the same, the kind of width, the ultimate like diameter and width of this cylinder are the same. It's just that one cylinder is twice as tall as the other one. So just kind of on the surface without doing any work, I could say, well, I'm pretty sure the volume of the larger figure is twice that of the smaller figure, but we can do some actual work to make sure we believe this fully. So let's go ahead and find the volume of both figures. Again, we can almost look at this and say, okay, the volume of the second one is twice that of the smaller one, or the volume of the smaller one is half that of the larger one, but let's do some work. So let's look at the volume of the smaller figure. So we have the volume is pi, which again, we'll use just 3.14, times the radius, which is 3, squared, times the height. We can type all of that into the calculator all at once, so let's go over to the calculator. So we have 3.14 for pi times the radius, which is 3. We want to square that. Use the right arrow to kind of leave that superscript world. And we want to multiply it by the height of that initial cylinder, which is 5. Enter, and we get 143.1. So we have that the volume of this smaller can, or the smaller cylinder, is 141.3 cubic inches. Now let's go ahead and find the volume of the larger figure. So the volume of the larger figure is still 3.14 for pi. The radius of the larger cylinder is still just 3 squared. But this time the height is 10. So let's go to the calculator and see what we get. So we're going to take 3.14 times 3 squared. We're going to hit the right arrow to leave that superscript world. We're going to multiply by 10. And this time we get 282.6. Okay? which kind of should be expected. So we get 282.6 cubic inches. All right. So we can see here the volume of the smaller cylinder is half the volume of the larger cylinder. If I take 141.3 and I multiply it by 2, I get 282.6. If I take 282.6 and I divide it by 2, I get 141.3. So it says a cylinder with radius 3 inches and a height of 5 has its height doubled. How many times greater is the volume of the larger cylinder compared to the smaller cylinder? I would say the volume of the larger cylinder is twice the volume of the smaller cylinder. So we could kind of just intuit that by looking at those formulas and realizing they're exactly the same, except one is being multiplied by 5, one's being multiplied by 10. Since 10 is twice 5, that tells us the volume of the smaller one is going to be half the volume of the larger one, or the volume of the larger one is double the volume of the smaller one. But we went ahead and backed it up. We just went ahead and found the volume of each, and we can see now clearly that the larger cylinder has twice the volume. So again, there's lots of different solid figures. We have cones, we have pyramids, we have obviously spheres, we have cylinders, lots of different shapes, rectangular prisms. They all have their own unique volume formula. So just know how to use them. That's the biggest thing. I'm not so concerned that you memorize these formulas. I'm more concerned that you know how to use them. All right. And just know that with pi, a lot of them are going to involve pi. Just make sure you understand how to estimate using pi. So frequently we'll use 3.14 or we'll use 22/7 in place of pi. All right.